I mean, the important point is that the internet is full. That's the tabloid headline. The internet is full. There's now so many machines attached to the internet that there is no way that they can all have their own unique address. Not the way we're currently addressing them. All right, well, the number is 4,294,967,296. A packet is what happens to the information that you're trying to send on the internet. Your computer breaks it down into bite-sized chunks and it sends it off bundled up. It's like putting it in an envelope. And on the front of the envelope, it writes this unique number, which is the IP address, and sends it off across the internet. And then every router, every switch that it encounters as it travels down the internet, looks at the number on the front and goes, I know where to send that. And it weaves its way, not in any unique manner. Actually, it's a very random process, but it weaves its way through the internet routers and eventually finds your machine. So essentially, every machine is addressed by a unique number, right? Because computers count, they don't have written addresses. And they're all designed in such a way that they are stored in a 32-bit number. Now, what that basically means is that you've got 32 lines of 1 or 0, right? It's a binary value. And that means that there must be some limit to how big a value you can store, right? And that value, well, if you remember, we did in the Pac-Man video, the biggest value you can store in an 8-bit number. Okay, well, that's 2 to the power 8. The biggest value you can store in a 32-bit number is 2 to the power 32. So, I mean, that's the headline. The internet is full, and what I mean by that is that on the 3rd of February last year, the authority that hands out numbers to the agencies that then manage who gets what address handed out their last value. So there are no more. So if you're now a new company and you want to set up a business and have your own website and have your own address for people to come and see you, there's none left. Simple as that. It's full. Well, I mean, there's various things that are being done to mitigate the problem. They're going back through the addresses that they've handed out in the past, and they're looking to see if they're being used. And if they're not being used, then they're harvesting them to hand them out again. It's not really going to solve the problem for very long. So we need to take a wholly new approach. And that approach is to throw away the 32-bit solution, as always with computers, right? You throw away the small ones. So when we used to have 8-bit computers and we could count up to 256 and that was fine, but eventually we wanted to count to more than 256, so we threw those away and we got new computers and they could count up to 65,536. And then we wanted to count to bigger numbers than that, so we threw those ones away too, and we brought in 32-bit computers, which is what most of our viewers will be using. And 32-bit computers can count up to 4 billion, which is quite a big number, but even that is beginning to reach its limit. So now we're starting to build computers that can count up to 2 to the 64. And I've just realized that you're now going to ask me what that number is, and I don't know. so down here we've got the 32-bit computers that we're now throwing away in our laboratory because we've moved on. We're on to 64-bit computing now, so we can count to really big numbers. Around your home, there's an awful lot of things connected to the internet, primarily your phone and your computer at the moment, but your tablet computer, and then there's crazy people who want to connect your washing machine and your fridge and your house's heating. There's all sorts of ideas about things you could connect to the internet. And every one of those needs to be addressed in some unique way, because if it's not got a unique address, then that introduces confusion, right? If two things have got the same address and I want to talk to them, if I'm a computer, which some people think, and I want to send information, then if two things have got the same address, I don't know which one of those two I'm trying to communicate with. Most businesses, like the University of Nottingham, where we are, have dynamic allocation of addresses. So you switch a machine on, and some server somewhere says, yes, you'll need an address, and hands it an address. And that's only valid for while it's switched on. But of course, the server can only hand out a certain amount of addresses. It's only got maybe 65,000 addresses that it can hand out, probably fewer than that. Obviously, at some point, it runs out. And that tends to be what's happening. The biggest problem that we're seeing at the moment is just dynamic allocation of IP addresses, a thing called DHCP, failing because companies are running out of their own IP addresses, and so they have to go back for more.
So for example, the university here, can only hand out from a finite number of addresses that it already owns.
That's right. It has to request addresses from a regional authority, and the regional authority here covers Europe and about half of Asia, Russia, and the Middle East. And then there are regional authorities for Oceania and China and Africa and Latin America and North America. And the regional authorities request addresses from an international authority. And if you trace it all back, eventually this is all funded by the US Defense Department, which is a little bit sad. No, I like the US Defense Department. They're good people. Oh dear. They've handed out the last of their IP addresses, right? They've handed out this many to the regional authorities, right? The regional authorities are expected to run out sometime this year. Problem. The solution to this problem is that we are going to change from IP version 4, which has been around since I think about 1981, sometime around then, and we're going to change to IP version 6. I don't know what happened to IP version 5. Now, IP version 6 is based on a 128-bit number. Now, 128 bits, just to put that in some sort of perspective, what that means is that every person can have billions upon billions upon billions of devices each, right? So we're not going to run out of space anytime soon with IP version 6. The problem now is a human problem. Right? There's a whole bunch of companies out there who are running the routers and the switches around the internet, which are passing information from one machine to another machine, that need to upgrade their routers to IP6, right? And they're not doing it. There's a very, very slow uptake, and purely for economic reasons, I presume. It's an effort, and you've got to pay somebody to make that effort, and so it's just not getting done. The adoption's appalling. The 8th of June 2011 and the 6th of June this year, 2012, were test days for IP version 6, where there was a certain amount of uptake. Companies were encouraged to switch on their IP6 and provide their material through IP6. And it all went smoothly, right? Nobody noticed. Brilliant. So we're getting there, slowly but surely.
The web address of Numberphile is www.numberphile.com.
Right.
What's going on there?
That's not its web address. That's some human readable form. So as well as providing you with a unique number, what your internet service provider is doing is using a thing called domain names. It has a table which ties that domain name to the unique number. Because if we were all having to wander around remembering the unique 32-bit number for all of our favorite websites, whether that is 60 symbols on Numberphile or TestTube, or you choose which one you like the most, we'd forget them, right? Because that's too many. So at some point, and I don't know when, somebody had the bright idea of just tying a meaningful name to these things, and that's what you're remembering.